We're going to solve the equation e to the power of 8y equals 7, but we want to compare two different methods. First off, again, remember, if you see a variable in the exponent, your first thought should be logarithms. When I have the power by itself, a really great go-to method is to do what I call log and lasso, because it moves the variable from the exponent spot to the front. If I use that method and I just use a basic logarithm, here's my original, and then I'm going to log both sides, and then I'm going to move the exponent to the front. Again, good notation. It's always a good idea to put your exponent in parentheses before you move it to the front. Sometimes that's overkill, but it will always lead you to the right answer. So lassoing that exponent to the front, I have 8y log of e equals log of 7. Now just really looking at what does that mean, this is 8 multiplied by y multiplied by the log of e. When you're solving an equation for y, we're thinking, okay, y is being multiplied by 8, and it's being multiplied by the number log of e. To get rid of multiplying by both of these numbers, we're going to divide both sides by both of the numbers. What I do to one side, I do to the other. So this 8 cancels this 8. Log of e cancels this one. And I have y by itself. I pick up my calculator and I enter this, and I end up getting about 0.24. Okay, now another strategy, yes, I'm going to log both sides, but I'm going to refer to this as the convenient log, because we have another property that if the bases match, everything disappears. So in this one here, the base is e. So if I choose the logarithm with the same base, it's going to wipe a lot of this out. So the logarithm with base e is a natural log. So instead of just plain log both sides, I'm going to take the natural log of both sides. We don't see it, but the base on a natural log is e. And what that just accomplished is when the bases match, that property says all of that goes away, and then my left-hand side is simply 8y. So I have 8y equals the natural log of 7. And now to get y by itself, all I need to do is divide by 8. So dividing both sides by 8, I'm going to have natural log of 7 divided by 8, and I end up with the same answer. Now just a little bit of notational information for you. We're going to solve one more with our shortcut. So I see a base e, so I'm thinking, okay, instead of log and lasso, I'm going to take a logarithm with the same base. So I'm going to natural log both sides, because that's a base e. When those match up, all that goes away, and all I have left is x minus 2 equals the natural log of 4. To finish getting this by itself, you want to add 2. So here's my ln of 4, and I add 2, and I just need to be careful here. Like, what does that mean? Do I mean the natural log of 6? This answer is fine, but you need to know that I think this is a little less confusing. Sometimes just notationally, this is why people, when they're writing out their answers, they put the logs last. So when I have a choice, I like to put my logarithm last. Another way to make sure that you are being clear in your answer, mathematicians were very lazy writers. And there is a set of parentheses around what you're taking the logarithm of. So if I wasn't lazy, I would put a set of parentheses around the 4 so that when I add over 2, I can clearly see that I'm taking the natural log of 4 and then adding 2.